Light is the most studied thing in the history of science, and there is still something about it that nobody can fully explain. Not the speed, not the wavelength, something deeper, something that sits right at the intersection of quantum mechanics and reality itself, and refuses to resolve cleanly into either a wave or a particle no matter how carefully you look. Start with what we know. Light is electromagnetic radiation, oscillating electric and magnetic fields propagating through space. James Clerk Maxwell described it mathematically in 1865. In 1905, Einstein explained the photoelectric effect by treating light as discrete packets of energy called photons, earning him the Nobel Prize in 1921. The photon is now a fundamental particle in the Standard Model, a boson with zero rest mass, zero charge, and spin 1. So light is a particle, except it is also definitively a wave. The double-slit experiment is where the strangeness becomes unavoidable. Send light through two parallel slits, and it produces an interference pattern on a screen behind them, alternating bands of light and dark, exactly what waves do when they overlap and either reinforce or cancel each other. That is wave behavior, classical and expected. But now send individual photons through one at a time, so slowly that only one photon is in the apparatus at any moment. There is nothing for it to interfere with. It cannot split and go through both slits simultaneously, in any classical sense. Yet over time, as thousands of single photons accumulate on the screen, the interference pattern builds up anyway. Each individual photon somehow encodes information about both slits even though it is a single discrete object. This is not a measurement problem or a limitation of our instruments. This has been tested with increasing precision for decades. The interference pattern is real. Each photon behaves as if it went through both slits. When you add a detector to determine which slit the photon actually went through, the interference pattern disappears and you get two simple bands: particle behavior. The act of obtaining which path information destroys the wave interference. The experiment changes its result based on what you choose to measure. The formal description of this in quantum mechanics is that the photon exists in a superposition of states. It has a probability amplitude for going through each slit. The wave function describes this superposition mathematically, but the wave function is not a physical wave in space. It is a mathematical object that encodes probabilities. When measurement occurs, the wave function collapses to a definite outcome. Here is what science cannot fully explain: why and how that collapse happens. This is the quantum measurement problem, and it is not solved. Different interpretations of quantum mechanics handle it differently. The Copenhagen interpretation says the wave function collapse is a fundamental feature of measurement, and it is not meaningful to ask what the photon was doing before it was measured. The many worlds interpretation says the wave function never collapses. Instead, every possible outcome occurs in a branching multiverse. Pilot wave theory says particles have definite trajectories guided by a real physical wave. Each interpretation reproduces the experimental predictions of quantum mechanics. None has been experimentally proven over the others. Beyond the measurement problem, there is something even more fundamental about light that resists intuition. Light travels at exactly 299,792,458 meters per second in a vacuum. This is a defined constant, not a measured approximation. It is the same for every observer regardless of their motion. This was experimentally confirmed by Michelson and Morley in 1887 and is the foundational postulate of special relativity. No matter how fast you move toward or away from a light source, you always measure the same speed. This is not just counterintuitive, it breaks every classical notion of relative motion. And while special relativity describes it precisely and consistently, the deeper reason why the universe has this specific speed limit, why light moves at c and not some other value, is not derived from first principles. It is an observed fact built into the foundations of physics. Light is the most precisely described phenomenon in science, and at its core, it still contains questions that no interpretation, no experiment, and no equation has fully closed. Follow for more on the deep mysteries hiding inside the most familiar parts of physics. And tell me, the fact that observing a photon changes its behavior, does that feel like a property of light to you, or a property of reality itself?